So now that we have this great conversion factor between grams and moles, it's important that we start to use it in some actual conversions. So let's look at a couple examples. Okay, so how about this simple problem? How many grams are in 25.6 moles of nitrogen? Well, the first thing that you're going to need is to write a good conversion factor, a good equivalence statement. So how are we going to convert between these grams and moles? Well, where I would start is by finding nitrogen on the periodic table. And again, looking at that average atomic mass, because that means that 1 mole of nitrogen equals 14.007 grams. The material in these problems is really important because the material is going to tell you the number of grams. So there's no one-size-fits-all equation, no one-size-fits-all formula for these problems. You will need to construct this individualized equivalence statement for every single problem. But luckily, it's not that bad. It's just find the number on the periodic table. Okay, so now that we have this equivalence statement, let's get started with our conversion. As with all good conversions, we're going to want to take what we've been given in the problem and put it over 1. So 25.6 moles was given in the problem, and that's specific to nitrogen. And notice that I took the time to put the nitrogen in the conversion math, and I just simply put it over 1. Now we're going to follow our good conversion rules, our good conversion steps. We know that we don't want the moles anymore, so we want that to cross down to the bottom of the next box to be able to cancel out. Now this is an important step because it's going to determine what math we're going to be doing in the problem. Because now I can fill in with the numbers from my equivalence statement. I know that the number in front of moles of nitrogen is 1, so I'm going to filter that 1 down to the bottom. And the second half of the equivalence statement is what's going to go in the top half of my fraction. So I just need to plug it in and chug out an answer. And in this case, I'm going to get 359 grams of nitrogen. Now, one important reminder, since we are using multiplication in this problem, the multiplication rules for significant figures is in play. Notice that I was given 3 significant figures in the beginning of the problem. 25.6 has 3 significant figures. So I need to limit my answer also to 3 significant figures, which is why I left it as 359. Now, this is really, really important as you move forward. So please, again, do pay attention to those significant figures rules. Let's try another problem. How about this? How many moles are in 18.5 grams of phosphorus? So again, the first thing that I want to have is a good conversion statement, a good conversion equivalent statement between moles and grams specifically for phosphorus. Look no further than the periodic table and write out your statement. 1 mole of phosphorus equals 30.974 grams of phosphorus. And now that I have that equivalent statement, now you can begin the conversion. So take what you're given and put it over 1, 18.5 grams phosphorus over 1. We don't want grams anymore, so let's drag that unit down to the next box. And notice again, I'm taking the time to put the substance in this. It might not seem like it makes a lot of sense now, but in a subsequent chapter, it's going to save you a lot of heartache. So please get into the habit now. Then, let's figure out what numbers go where. So notice I have grams in the bottom box. That means that I'm going to take that 30.97 grams and put that to the bottom. And then the second half of the equivalent statement is going to fill into the top. Fill it in, plug and chug. So my final answer in this case, with 3 significant figures, because of the 18.5 only having 3 significant figures, would be 0.597 moles of phosphorus. Now, before we leave this problem, I just wanted to point out, notice that I used the abbreviation MOL. The abbreviation MOL is not short for molecules. MOL is the abbreviation for mole, MOLE. And yes, I know it's ridiculous to have that as an abbreviation because it only drops 1 letter, but it's pretty common in the scientific community. So if you see this, again, it's referring to the number of moles, not a number of molecules. Let's try another problem. How about how many moles are in 18.5 grams of sodium phosphide? Now, we've got an issue here because this is not just a single element, this is a whole compound. So we're going to need to get to that molar mass of that compound before we can continue. We need that equivalence statement. So write out the chemical formula for the sodium phosphide. In this case, it's Na3P. And you can see the little tiles for the sodium and the phosphorus. I would want to add together 3 sodiums and 1 phosphorus. And that leaves me with the molar mass that 1 mole of sodium phosphide is equal to 99.944 grams of Na3P. Now we can start our problem. So we take what we're given in the problem, 18.5 grams, and put that over 1. Again, the unit we do not want is going to slip down to the bottom of the next box. And then let the equivalent statement that you wrote do the talking. We know that grams is going to go in the bottom, so simply drag the number for grams down to the bottom, 99.944. And the second half of that equivalence statement goes to the top, 1 mole of Na3P. Now you're ready to plug and chug. And the final answer for this one, again with 3 significant figures, should be 0.185 moles of sodium phosphide. Good luck with these conversions, and just make sure that you're very careful to pay attention to making sure that you write out your units. Be careful with your sig figs, so the sig figs in should be the sig figs out, and be really careful with calculating a good molar mass. That's really going to be triggered by having a good crisscrossed chemical formula. So please take your time to do it right.